Hello guys, today we'll be discussing about sampling, and in this lecture we'll discuss what sample and sampling is, what the difference between population and sample. We'll discuss about the different criterias and procedures to be considered in taking samples, and we'll discuss the different techniques of sampling and so on. So let's start by defining what sample and sampling is. So when you say sampling, it is the process of taking relatively smaller number that represents from the whole population, that represents the whole population. So when you say sampling, it is just the process of taking a representative from the whole population, and when you say sample, it is the elements or the characters that represents the bigger population. Assume that let's say in a certain country A we have 1 million or 2 million customers that consume a certain product B, let's say. So the population is the 2 million individuals who consume that specific product. So when you say a sample, it is a smaller portion from the whole population, from the 2 million, but this sample will be used to represent the larger population, the 2 million population. So when you say sampling, it is the technique, it is the process of selecting a smaller amount that represents the whole population. So this is what sampling is. When you say sample, it is the actual character or the elements that represents the population. So if you take the whole population, if you include the whole population in your study, then it is known as census. But if you take a representative sample from the population, then it is known as sampling. So be reminded, there are four terms in here: sampling, population, census, and that of sample. Sampling is when you take a smaller representation from the population, and census is when you include the whole population in your study. Sample is the smaller portion of the elements when population is the whole bigger picture. So in taking samples, in conducting sampling, when you design your sampling techniques, when you select a sample, there are 5 basic questions that you need to address, you need to answer. So the first question is it required to take samples or is it not? So to answer this, if the population is smaller in size, let's say if it is 100 or 150 customers or below 100, then you need to include all population in your study. So most authors agreed that if it is below 100, then you need to include the whole population. You need to take the whole population and conduct research using those 100 population. But if it is more than 100 population, okay, if the population size is more than that, then you could take samples. But the first question is it mandatory to take samples or is it not? Is it better to take samples or not? If the population is smaller in size, then it is advised to include the whole population. If the population is larger in size, then it is advisable to take samples for different reasons, of course. The second question that you need to address as a researcher is what process should be followed in selecting the samples. There are different process, there are different techniques for that matter. Basically, of course, you have the very well-known sampling approach, or the probability and the non-probability sampling approach. We will discuss about that later on, but you need to understand which sampling process, which steps should be followed in selecting the sample from the population. If the first question is yes, then you'll continue to the second question. If the first question is no, then the rest of the question could not be addressed, because uh, the second, the third, and the rest of the questions are applied when you select samples. The third question that you need to address is what kind of sample should be taken or included in your study. There might be different samples, different characteristics, so you need to understand which characteristics should be included in your study. Let's say, for instance, you could categorize your samples in terms of age and in terms of gender characteristics. So you need to address should all age groups be included in the study as a sample, or uh, should there be a distinguishing factors to select from those samples. So you need to understand their characteristics in selecting the sample and include it in your research. Then the fourth is about sample size. So how large should it be, your sample? Should it be larger in size, or should it be smaller in size? This To determine this, we have different factors to be considered, and there are different techniques that will help you to select the sample size. So the first question is about the sample size that you need to take in conducting research. So it is about how large should your sample be. Should you take 100? Should you take 200? Should you take 1,000? Or how much should you take as a sample from the whole population? The fifth question that you need to address is how you are going to control and how you are going to adjust the errors that might occur. In the previous lecture, when we discussed about research design, we have discussed about non-response errors and response errors. So you need to prepare how you are going to adjust these errors, especially the non-response errors. How you are going to adjust these non-response errors. So you need to come up with a strategy for compensating the non-response errors. So census, population, sample size, sampling techniques, and the others should be considered in selecting and understanding whether you need to take a population, or you need to take samples in uh, gathering data and conducting your research. So it's just like a summary. A census is when you include the whole population in your study, but a sample is a representation of that bigger population. So sampling is a technique of selecting uh, from populations, and census is when you include the whole population. So saying that, let's see what the difference between sample and census, and how you are going to choose between samples and that of census. Because if you remember, the first question that you need to address is should a sample be taken or not, right? So let's see the difference between sample and that of census, and we'll see how you are going to select between sample and of census. The budget that is required in taking samples and census. When you take samples, when you take representations from the whole population, the budget that will be required is smaller. But if you take census, if you conduct census, meaning if you include the whole population in your study, the budget that will be required will be large. So in here, if you don't have a larger finance, then you are going to conduct samples. But if you have a larger finance, if you have the capital, then you are going to conduct census. You could conduct census. The other, the time availability and the time requirements. Uh, if you don't have that much of time, then go for samples, but there are disadvantages and advantages, of course. I'll come back to that. But if you have shorter period of time, then it's better if you take samples than including the whole population in your study. So the time that is required to gather data from a sample is shorter, but when you gather data from the whole population, it will take a longer period of time. Let's see one example to make these two a little bit clear. So assume uh, there are 2 million customers in the market, in the industry, that consumes a certain product. So if you are going to gather data from those 2 million customers, then you need a larger sum amount of money and you need to have a longer period of time. But assume you want to take samples and you took, let's say, 500 or let's say 1000 customers as a sample. So when you collect data from 1000 customers, then you need to have a smaller budget. You are going to assign a smaller budget and you need to have a shorter period of time. So this is the difference between the two, when you took sample and when you include the whole population in your study. So these are the two factors. The third factor is the population size. uh, the population size, if you have a larger population size, then you are going to take samples from that population, and if the population size is smaller in size, then you are going to include the whole population in your study. Let's say if the population size is 100 customers, then you are going to gather data from those 100 customers, and you don't take samples. You don't take 5 or 10 customers, and you are not going to conclude about the 100 customers. So if the population size is larger in number, you are going to take samples. If the population size is smaller, then you are going to conduct census. So this is the other difference between sample and that of census. Characteristics, variance characteristics. If it has smaller variance characteristics, meaning if they are somehow homogeneous, then you are going to take samples. But if the population is heterogeneous and if the characteristics variance is large, then you are going to conduct a census. But there is no, I mean, you are not going to see only one factor to decide whether you are going to take sample or you are going to conduct a census. So these 8 factors goes together. If the budget is this, then you are going to take sample or census, and you are going to tick, and you are going to take the average, and you are going to decide whether you are going to take samples or you are going to conduct a census. So these are the different factors that will help you to understand, to decide whether census is mandatory or sample is better. So as I said, you are going to see all the 8 variables rather than only focusing on one variable because of different reasons. For instance, if you only focus on the financial requirement and ignore the others, you might commit errors and you might not get appropriate information about the population under study. So you might give different weights. All right, you might give bigger weight for one and you might give smaller weight for the other, but you are going to focus all the 8 factors to decide whether to take samples or whether to conduct a census. So these are the considerations to address the first question that we have discussed in here. So saying that, uh, what are the steps or the processes that you need to follow in selecting sample in the sampling process? So it is known as sampling design process. So the first step is define the target population. You have 6 steps, but the first step is you have to define the target population clearly, and then after defining the target population, you are going to determine the sampling frame. So we'll discuss what sampling frame and what population is. Of course, we have discussed what population is already, and we are going to discuss what sampling frame is. After determining the sampling frame, you are going to select between the sampling techniques. Okay, there are different sampling techniques. So you are going to select which sampling technique you are going to choose. After selecting the sampling techniques, you are going to determine the sample size. So the sample size, we have uh, raised these questions in uh, the fourth and the second and that of the third. Okay, so after determining the sample size, you have 3 techniques. Of course, we'll discuss about that later. So after determining the sample size, you are going to execute the sampling process. You have laid the plans in here. So after laying the plans, you are going to execute the plans at this stage, and the last stage is a type of validating the sample controlling stage. Okay, so you are going to validate whether the samples are appropriate or not. So these are the 6 steps that you are going to follow at the highlight. So let's discuss each step one by one. So as we said, the first step is you are going to define the target population. So we have said a population is a collection of elements, or the whole picture, the bigger picture. So it is the elements, it is the respondents that you are interested to gather information from. So this information are available in this population. So let's say you want to conduct whether your advertisement is effective or not. So the population might be certain countries uh, citizens, all right. So citizens that live in a certain country. So these are the targets population. So we are going to uh, determine and you are going to define your target population. Again, let's say you want to study the impact of uh, waste materials that is released from factories. Okay, let's say. So the population might be uh, the the uh, the societies that live at that specific factory area, or it might be uh, uh, the societies that live in that country. So these are the target population. So when you say target population, it is a cumulative, a collection of elements in which you as a researcher likes um, uh, to get information from. Okay, so this is a target population. So when you define your target population, you should make sure the target population are precisely defined. If the population is not defined well, if the population is imprecisely defined, then the whole thing will be in jeopardy. All right. so your research results will be ineffective, or the results that you get will be misleading. Okay, this should be considered. So let's say one more example, right, in the population. Let's assume you want to study the health effect of cigarettes. Okay, so the population uh, could be, those individuals who live in a certain country. Okay, or it could be those individuals who live in smoking areas. So this might be your population. But if you are going to define your population, like, let's say, non-smokers, okay, you might not get the results, the correct results, because they are not smoking uh, any cigarettes. Okay, so your research is the health effect of smoking cigarettes. So you should focus on those individuals who smoke, or who live around those individuals who are smoking. So uh, precisely defining your target population means everything, because if you uh, define your population wrongly, then the results that you'll be acquiring will be misleading, or it will be ineffective. So in defining your target population, you should understand the problems first. The problem that you defined should be precise, and should um, link with your problem statement. Okay, so your population uh, defining is basing on the problem statement that you have designed. So uh, in defining your population, when you determine your population, there are different things that needs to be considered. The first one is the elements, meaning the objects should be, the objective should be identified, and then you are going to identify the sampling units. Okay, and then you are going to see the extents, meaning the geographic boundaries, the geographic locations, and then you are going to consider time. Okay, so the period under consideration, which uh, period you are going to focus. So these basic things should be considered in defining your target population. So that's the first step, defining your target population. So be reminded that whenever you define your target population, you should understand your problem statement. You should understand what objective do you have, what goal do you have, and then you are going to define your population precisely. So the second step is determining the sampling frame. So when you say sampling frame in population, a sampling frame is a subset of your population. Let's say in the previous example I have given you, we said that the population might be the society that live in a certain country. So the subpopulation, which is the sampling frame, could be the societies who live in a certain location from that specific country. So the sampling frame is the subsets of your population. It is uh, uh, you know inside your population. Let's say if you want to study, if you want to conduct a research on um, uh, waste materials that is released from the factory, the impactors. So the population might be uh, the people that live in that specific factory, but the sampling frame might be the public, the local public, it might be the employees, it might be you know, the customers that live in there. So sampling frame is a subset of your population. So this sampling frame could be acquired from different sources. You could have the listes from different sources. So uh, this is the difference between population and sampling frame. It is a focal area. Okay, so population is the general thing, and sampling frame is the focal area inside the population. So uh, you can get the listes, but you might encounter a sampling frame error if the sample frame is omitted from the list, or the wrong sample frame is included in the list, then you are going to encounter with sampling frame error. So the sampling frame is just the list. So these lists could be from acquired from directories, from customer database, or from uh, commercial organizations, and so on. So uh, you might get the lists, but the sample frame, you know, the lists might contain samples or lists that should not be included in the list, or you might even omit some of the elements from the list. So you will be encountered with sampling frame errors. So this is the second step. The first step is defining the population, and the second step is determining the sampling frame. The third step is identifying and selecting the sampling techniques. So we have different sampling techniques. We have Bayesian sampling technique, or we have traditional sampling approach. You might even have sample with or without replacement, and you have non-probable sampling and probable sampling. But the very well known and the very used sampling technique is the non-probable sampling, and that of the probability sampling approach. So as you see in the diagrams, the sampling techniques is classified under two: probability and that of non-probability. In the probability sampling, you have four sampling techniques, and in the non-probability, you also have four sampling techniques. So we'll discuss these sampling techniques one by one. So let's start by defining what non-probability sampling and what probability sampling is first. So when you say non-probability sampling, these sampling techniques focuses and relies on the judgment of the researcher, while the probability sampling relies on chance. Meaning, if you are going to use non-probability sampling, then there is no equal chance of the sample to be included in your study, and there is no equal chance of the samples to be selected. So it is known as non-probability sampling, and it is completely relies on the judgment of the researcher. But if you say probability, if you are going to use probability, then it is based on chance, and the sample to be drawn from the population will have equal and similar non-zero chance to be included. So uh, when you are going to use non-probability and that of probability, there are different criteria that you need to consider. So if you have let's say the list is the complete list of the population, the sample frame, that means, okay, if you have the complete list of the sampling frame, then you could use probability sampling. But if you don't have the whole list of the sampling frame, then you are going to select non-probability sampling. So this is one major criteria for selecting non-probability and that of probability sampling. So saying that, let's discuss the techniques under probability sampling first, and we'll continue with the lists under non-probability. So in the probability sampling, we have simple random sampling. So simple random sampling is also known as lottery method. It is the same thing. Lottery method and that of simple random sampling is similar. It is interchangeable to the other name for one another, right? Simple random sampling is also known as lottery method, but widely it is used as simple random sampling. So in the simple random sampling, you are going to have the lists of your sampling frame, and then you are going to code the sample frames. Each and every sample frame will be given a number. Of course, you have two means for drawing sample from using simple random sampling. Or one is the automated way, and the other is the manual or the traditional way. Okay, so you are going to number each sample frames, and then you will put that sample frame, the labeled ones, in a jar, and then you are going to pick one at a time. All right, you are going to pick from the jars, and whatever number you get associated with the sample, with the individuals, will be included to be to draw or to get information from. So this is one method. Again, you could use tables to draw samples using simple random sampling, and then you have computerized system that will help you to draw samples using simple random sampling. But first you need to have the list, the random list. You are not going to include it in alphabetic or whatever it is. You are going to have a random list, and then you are going to assign numbers for each list, and you are going to put the numbers in the jars, and then you are going to draw uh, one at a time, and whatever number is drawn from the jars will be included in the research. So it is known as simple random sampling. So it is a kind of lottery method, how lottery winners are drawn from the jars, so that's why it is known as lottery method. So this is one approach in probability sampling. So there is an example in here you can read. So let's assume there are 1000 stove owning customers. So if you want to take a sample from 1000 stove owners, you are going to list these 1000 stove owners customers, and then you are going to assign number for 1000 stove customers, and then you are going to put it in a jar, and then you are going to draw from the jar one at a time, and whatever number is drawn from the jar will be included in the research. So you have two ways. One is the manual way, and the other one is computerized. The same thing happens in the computerized. You are going to feed the lists in the computers, and the computer will randomly select from the list, and whoever is drawn, then that uh, customer will be selected to be included in the research. So this is one simple random sampling. The other is systematic random sampling. The difference here between systematic random sampling and that of simple random sampling is in the systematic random sampling you are going to use a certain gap, so you are going to use a formula for that. The eyes element or the eyes gap. So after listing the sample frames, you are going to draw, let's say if you want to take uh, 10 I mean 100 customer from 1000 customers, then you are going to use this formula. I is equals to capital N over small n. So I is the gap or the elements of succession. Capital N is the population and small n is the sample. As we said, let's assume there are 1000 stuff owning customers, and then you want to take 100 from 1000 customers. So the population is 1000, the sample is 100. So by dividing 1000 with 100, you are going to get I as 10. So every 10th customer will be selected as a sample to be included in the research. So first there are two steps, all right. The first step is selecting or calculating the eyes value, and then after that you are going to select randomly from 1 to 10 because eyes value is 10. If the eyes value was 100, then you are going to select randomly one from 1 to 100, and then you are going to start and you are going to add eyes step. So going back to the example, there are 1000 customers as a population. We are going to take 100, then the eyes value is 10. So first you are going to pick a number from 1 to 10 randomly. So let's say you picked 10 as a starting point. So uh, the, the customer at the tens number will be included in your research, and then you are going to add 10, and then number 20. Okay, the customer who is in 20s list will be included, and then in the 30s. Okay, so every tens um, uh, list will be included in your research. So the customers in number 10, number 20, number 30, 40, and so on will be included in your research until you get 100 customers. But the thing is in here, what if the customer at the tens level or at the tens list is out of reach? So you are going to go up one and you are going to select number nines. Okay, the customer who is at number nines will be included in the research, or you are going to add one and the customer who is in the 11th list will be included in your research. So this will be systematic random sampling. The difference between simple random and out of systematic is that in the systematic random sampling you are going to use formulas and you are going to select in the elements of succession. So I is known as element in succession. So this is the second technique. The third technique is known as stratified sampling. So stratified sampling is also known as random quota sampling. So in the stratified sampling, first you are going to divide your population, but the population will be divided in a homogeneity, meaning each strata should be homogeneous, should have similar characteristics. And then after that, after dividing the population in a strata, so the strata has homogeneous characteristics. So you are going to select randomly from each group. Let's say in the diagram as it is shown, we have four stratas: strata 1, strata 2, strata 3, and that of strata 4. So the elements in the strata 1 is homogeneous. They has similar characteristics, similar natures, and the elements in strata 2 will have similar characteristics and similar natures. But comparing between strata 1 and that of strata 2, they will have different characteristics and different natures. So just to make it simple, let's assume you classified your strata, you divide your strata, I mean the population, in terms of gender. So let's say those individuals in strata 1 are male and those individuals in strata 2 are female. So in terms of characteristics, those individuals in strata A or in strata 1 has similar characteristics, which is male, and in strata 2 which is female, they have similar characteristics. But when you compare these two stratas, they will be having different characteristics and different natures. So that's the first one. The first one is dividing the population in strata, and then each strata will have a homogeneous characteristics, and after that you are going to select randomly from each strata, from all the four stratas, and you will have a combined single sample. So this is known as stratified sampling or random quota sampling. The fourth and the last in probability sampling is known as cluster sampling. So the difference between stratified sampling and that of cluster sampling is that in the cluster sampling you are going to use the same step. You are going to divide the population, but when you divide the population into clusters, each cluster will have heterogeneous characteristics, meaning cluster 1 will have a heterogeneous characteristics, cluster 2 will have a heterogeneous characteristics, but when you compare cluster 1 and that of cluster 2, you'll have a homogeneous characteristics. But if you see in the stratified sampling, strata 1 has homogeneous characteristics, strata 2 has similar characteristics, is the homogeneous. But when you compare between the stratas, meaning strata 1 and strata 2, when you compare the two, they will have different characteristics. It is heterogeneous. But in the cluster sampling, cluster 1 will have heterogeneous characteristics, heterogeneous nature. Cluster 2 will have heterogeneous nature, but when you compare between cluster 1 and that of cluster 2, they will be having a homogeneous nature. So in the cluster sampling, you are going to select the group as a whole. So after dividing the population into clusters, you are going to pick one or two clusters basing the sample size. But in the stratified sampling, after dividing the population into stratas, you are going to pick a sample from each strata. But in the cluster, after dividing the population into clusters, you are going to pick one or two clusters basing your sample. So these are the sampling techniques in probability sampling approach. In the non-probability sampling approach, we have four. So namely, we have convenience sampling. So the convenience sampling is also known as accidental sampling. So it is the same. Convenience sampling, accidental sampling, they are all the same. So we have said non-probability sampling, the selection is dependent on the researcher's judgment. But when we say probability sampling, it is based on chance. You are not going to interfere. As a researcher, you are not going to involve your judgment as a researcher if you are using probability sampling. But if you are using non-probability sampling, then it is dependent on the judgment of the researcher. So in the convenience sampling, uh, the respondent sample is left entirely for the researcher. The researcher will judge and select the sample. So convenience sampling or accidental sampling is when the researcher picks a sample based on his or her convenience. But there are assumptions in here. The assumption is that in selecting convenience sampling or accidental sampling, the target population is homogeneous, meaning the population will have similar characteristics, similar nature. So there is no difference if you select from different uh, areas. So that is one assumption. But if the population doesn't have homogeneous characteristics, convenience sampling might not be working, and you might uh, face with sampling errors. Okay, you might face with sampling errors if the population is not homogeneous. So that's the assumption. The population is homogeneous, and it is left entirely for the researcher's judgment, and it is based on the convenience that the researcher sees. So it is known as convenience. It is emanated from the name. Let's assume an example. You want to get information from a mall. Okay, such a mall, and if you are using convenience sampling, uh, you went to the malls and you are going to distribute questionnaires for whomever you get in that specific mall. So it is accidental. You are not being selected by chance, but I mean you are going to be selected uh, because you were purchasing or visiting the malls. If you are not at the mall, you will not be selected. So it is known as accidental and convenience sampling. But if you are using probability sampling, uh, you it's not because you were at the mall, but the questionnaire will be reaching you because you are a customer of that specific mall, wherever you are. Okay, whether you are at the mall or whether you are not at the mall, the questionnaire will eventually reach you if you are using probability sampling. But if you are using non-probability sampling, and if you are using convenience sampling or accidental sampling, the questionnaire will reach you because you were found at the mall. So it is known as convenience sampling and accidental sampling technique. The second is judgmental sampling or purposive sampling. It is the same. So judgmental sampling, it's an extension of convenience sampling, but the difference between judgmental sampling and that of accidental sampling is that uh, in the judgmental sampling, the respondents are being selected based on the experience that the researcher has. Okay, based on the experiences. Let's say if you are about to dispatch questionnaire as a researcher in a certain mall, and if you ask the customer for how long he or she has been purchasing from that mall, and if you only pick a customer who has been purchasing from that specific mall for more than a year, then it is known as judgmental sampling. But if you are going to dispatch the questionnaires regardless of whether that individual is a customer or not, whether that individual has been purchasing from that specific mall for more than a year or two. uh, you just If you just dispatch the questionnaire just because he or she was purchasing or visiting the mall, then it is known as convenience sampling. But if you include your experience, your judgment, let's say if you are going to dispatch questionnaire for customers who have been purchasing for more than a year at that mall, then it will be judgmental sampling. So this is the difference between convenience sampling and that of judgmental sampling. The third is known as quota sampling. So when you say quota sampling, it is a procedure by which the researcher uh, controls the number of respondents at that specific area or with specific criteria. Let's say you went to a mall as a researcher, you are going to collect data from customers, but you set a criteria saying that you'll be collecting uh, 50 questionnaires from females, and you are going to collect uh, 30 questionnaire from males. Then it is quota sampling. You are going to control the number of respondents based on a certain criteria. It might be based on geographic location, it might be based on age, it might be based on gender, it might be based on income, and so on. So when you say quota sampling, it is when the researcher delimits or controls the number of respondents. But in the quota sampling, you will be having uh, two stage. So the first one is we are going to determine the numbers, and then the second is you are going to use judgmental or convenience sampling. By itself, quota sampling could not be applied. So it is a two-stage restricted judgmental sampling. Either you are going to use convenience or you are going to use judgmental type of sampling, but more of you are going to use convenience sampling along with quota sampling. The fourth is snowballing or snowball sampling. The other name for snowball sampling is known as referral sampling. So in here, what you are going to do is you are going to select a respondent, okay, randomly. So there will be one initial group that will to respond for your questionnaire or for your interview, and then after interviewing that individual, you are going to ask the individual for a referral to tell you other individuals who could help you in providing information. So it is known as snowball sampling or referral sampling. So you have two steps. Number one is you are going to select one individual, one initial group. After interviewing that group, you will ask that group to refer you to another group or another individual so that you can interview the second group. So in here, in snowballing, you are going to use it if the target population is rare, and if the target population is unique, and if the target population is unreachable, okay, nearly impossible to address those populations, or nearly impossible to get those information, those individuals to collect information. And again, you are going to use snowballing if the sample is smaller in number. So in a review, we have two types of sampling technique. Wait, let's go back to the diagrams here. Yes. Okay, in the sampling technique, you have two approaches. You have probability sampling approach and you have non-probability sampling approach. If you are using probability sampling approach, then the population to be included as a sample will have the same chance, non-zero equal chance. But if you are using non-probability, then the sample, the population to be included as a sample will have a zero chance. All right, it is entirely dependent on the judgment of the researcher, and the probability it is dependent on chance. In the probability section, okay, in the probability section we have simple random sampling or lottery method. So in here you are going to list the sample frame, and then you are going to assign number for each sample frame, and then you put it in a jar and you are going to draw one at a time. So it is known as simple random sampling. Systematic sampling, instead of drawing and labeling, you are going to use a formula. So I is equals to capital N over N, and then you are going to list. After listing, you are going to draw every i's element. So it is known as systematic sampling. Stratified sampling is the other one. So you are going to divide the population into strata, and then each strata will have a similar characteristic. It is homogeneous, but compared between two stratas, they will have heterogeneous characteristics, and then you are going to pick from each strata. If it is cluster sampling, then you are going to divide the population into clusters, but in here each cluster is heterogeneous, but compared between the two clusters it is homogeneous, and you are just going to pick one or more clusters. So it is in the probability sampling. In the non-probability, you have convenience sampling, judgmental sampling, quota, and that of snowballing. So when you say convenience sampling, it is dependent on the convenience of the researcher, and it is accidental. When you say judgmental, it is similar with convenience, but the difference is it is based on a certain experience of the researcher. When you say quota sampling, it is a process of delimiting and controlling the number of samples to be drawn based on a certain criteria. And when you say snowball sampling, you are going to interview one group at initial, and you are going to ask for referral from that specific group. So these are the sampling techniques. So the third step, after selecting the sample, after picking from the samples, you are going to determine the sample size, how much to be drawn. Okay, I'll come back to this, but let's finish the steps first, and we'll discuss about the differences. So the first step is determining the sample size. So in determining the sample size, you have to consider two factors, the quantitative factor and that of the qualitative factors. So the qualitative factors includes nature of research and expected outcome, and then you have nature of analysis and so on. So these factors determine the sample size to be drawn in qualitative issues. The quantitative issues include variability of population characteristics, and then level of confidence, and degree of precision, and so on. So these are the quantitative issues that you need to consider in selecting the sample size. So all in all, you have basically three means or methods in determining the sample size. One is you could use other researchers' suggestion, or two, you could use sample size tables, or the third, you could use formulas. So number one, this is a suggestion of Malhotra and Briggs, which is published in 2006. So these are her suggestions. Let's say if the type of study is problem identification research, like that of market potential, then the minimum size will be 500, but the typical range is between 1000 to 2500. If it is problem-solving research, like that of pricing, the minimum size will be 200, and the typical range will be between 300 to 500 respondents. So this is one step. So it is simple, it is easier, but there is assumption in here too. So this is the first step, or the first technique in selecting sample size. The other method is determining sample size from already existing sample size tables. So the sample size tables are designed using formulas. So you have the precision levels, and then you have the confidence level, and then you have P, which is the proportion of samples. So in here you have the population size. If the population size is between 500 to 1000, and with the precision level of 3%, then you are going to include all the population as a sample size. But if the population size is between 500 to 1000, the same population size but with different precision level, now the precision level is 5%, then you are going to take between 222 to 286 respectively. So whenever the precision level increases, then the sample to be drawn will decrease as you see it. If the population is more than 100,000, okay, if it is bigger than 100,000, then you are going to take the sample size based on the precision levels indicated in here. So these are the two tables. The first table is you know, the population size starts from 500 to more than 100,000, but the second table it starts from 100,000, 100 to that of 450. So in the 3% precision level, if it is the population, if it is between or less than 450, you are going to select the whole population as a respondent. Okay, be reminded of that. If the precision level is 3%, and if the population is lower than 1000, then you are going to take the whole population as a sample, and you are going to conduct a census. It is known as census. But if the population size is between 100 and that of 450, then with different precision levels you could take different samples. So from the table you could understand that if the population size is below 100, whatever the precision level is, you are going to conduct a census. There are assumptions in here for the tables, so you could read the assumption. There are first assumption and second assumption, so you could read from the assumptions and you'll have a better understanding of using the sample size tables. The third is using formulas. So I will discuss two basic formulas in here, one for non-probability and one for probability sampling. So if you are using non-probability, meaning if the population size is not known, if you don't have the list, then you are going to use these formulas. So n naught is the sample size, z is the abscissa of the normal curve. So you could acquire z value from statistics tables, and p stands for, or p is the proportion of attributes, and q is 1 minus p, whereby E is the desired level of precision. So you could use this formula if you are applying non-probability, meaning if you don't have the list of the sampling frame, if you don't have the exact numbers, meaning the population size of uh, the sampling frame. So for example, okay, suppose we have a certain number of customers. We don't know the customers, but the proportion is 0.5. So with a desired confidence level of 95%, and with the precision level of plus or minus 5%. So we don't know the exact number of the population, so you could use the formula I have provided you here. So z value, okay, you could acquire the value from statistics table at confidence level of 95%. So at a 95% confidence level, the value will be 1.96. P is 0.5. So as we said, Q is 1 minus 0.5, which is 0.5. So when you compute this, you'll get 385 for as a sample. So you are going to gather a data from 385 farmers to draw a conclusion about the population. But be reminded that if you are using non-probability, the sample that you have drawn might not help you to conclude exactly about the populations, because you never know the exact population. But you could conclude something about the population using these samples, but still there might be errors. The other formula will help you in identifying the sample size when the population is known. So it is used for probability sampling, all right? So n is the population. This capital N is the population. Small n is the sample size. E is the precision level. So let's assume you have 2,000 customers or farmers that will be impacted. So you want to have 95% confidence level and 5% precision level. So when you compute these numbers in the formula, you will get 2,000 divided by 1 plus 2,000 multiplied by 0.05 square. So you are going to change the percentage into decimal numbers, right? So 5% means 0.05. So computing this, approximately you will get 333 farmers. So meaning you are going to interview 333 farmers to conclude about the 2,000 farmers. So this will have a better understanding, a better precision. So whenever you increase the precision level, let's say if the precision level is 6%, okay, you can calculate it yourself. If it is 6%, definitely the sample size that you will be drawn will be less than 333. So you can calculate by computing or using the precision level as 6%. You can calculate it as 7%. Okay, you can check it for yourself. You can pause the video and check it if the sample size will increase or decrease whenever you increase the precision level. Okay, so after determining the sample size, what you will do is you are going to execute the sampling process. In here, when you execute the sampling process, you are going to implement whatever you have designed. You said you are going to implement convenience sampling or stratified sampling, then you are going to apply convenience sampling or stratified sampling. And then if you have said you are going to include 333 farmers in your study, then you are going to include 333 farmers in your study. So it is implementing the sampling unit, the sampling frame, the sampling technique, the sample size, and so on. So it is the implementation step. But in the implementation step, you should know that you should follow exactly what you have planned. You don't have to deviate from your plans. And the last step will be validating the sample. So whenever you validate the sample, it is checking for sampling frame errors and screening the respondents in the data collection phase, and checking the implementation is correct or not according to the plan. So these are the 6 steps in determining the sample. So going back to the differences between non-probability sampling and that of probability sampling, when you are going to use non-probability sampling and when you will be using probability sampling. So these are the factors again. If based on the nature of the research, if it is exploratory type of research, then you will use non-probability sampling. You can conduct non-probability sampling. If the nature of the research is conclusive type of research, then you are going to apply probability sampling. We have discussed about exploratory type of research and conclusive type of research in the previous lecture when we discuss about research design. So you could summarize, you could refer that video lecture to understand what exploratory and conclusive research is. So relative magnitude of sampling and non-sampling error, again we have discussed what sampling and non-sampling error in that previous video, so you can refer to that. So in terms of magnitude, if non-sampling errors are large, then you can use non-probability sampling. But if the sampling errors are large, then you are going to use probability sampling. And then if in terms of variability in the population, if the population is variable, if it is heterogeneous, okay, if it is heterogeneous, meaning if it is there are higher heterogeneity in the population, then you are going to use probability sampling so that you can address, and you are going to include every population, I mean every sample, every characteristics in your sample. But if the population is homogeneous, if the population have similar characteristics somehow compared to heterogeneity, then you are going to use non-probability sampling. In terms of statistics considerations, okay, if the statistics considerations are unfavorable, meaning if you don't have the numbers and so on, if you don't know the exact number of the population, then you are going to use non-probability sampling. But if the statistical consideration is favorable, then you are going to use probability sampling. Operational consideration, meaning if you can if the operation is favorable, if you can gauge enough sample, then you are going to use non-probability. But if the population is disturbed, and distributed accordingly, then you are going to use a non-probability sampling. So these are the factors that you need to consider in choosing between non-probability sampling and that of probability sampling. So in a summary, we have discussed the 6 steps of sampling process, and then we have identified the different types of uh, sample techniques, sampling approach, and then we have seen the different sample size determination techniques or methods. So this will be at the end of the today's lecture. So thank you very much and stay safe.